Portable ground fault circuit interrupter protection, often referred to as GFCI protection, when utilized by personnel, does indeed satisfy the requirement for GFCI protection on temporary receptacles. This means that instead of relying solely on GFCI-protected receptacles, the use of portable GFCI devices provides an acceptable means of ensuring electrical safety in temporary power setups. The purpose of GFCI protection is to quickly de-energize a circuit when it detects a ground fault, which is an unintentional electrical path between a live conductor and ground. This rapid interruption of power helps to prevent electrical shock and electrocution, significantly reducing the risk of injury or death to personnel working with electrical equipment. In the context of temporary power, such as that used on construction sites, at outdoor events, or during maintenance activities, the electrical environment can be particularly hazardous. Factors like exposed wiring, damp conditions, and the use of portable tools increase the potential for ground faults. Therefore, the National Electrical Code, or NEC, and other relevant safety standards mandate the use of GFCI protection to safeguard workers. When considering GFCI protection for temporary receptacles, there are generally two primary approaches. Firstly, the use of GFCI protected receptacles, which are permanently wired into the electrical system and provide GFCI protection at the point of use, and secondly, the use of portable GFCI devices, which can be plugged into standard receptacles to provide GFCI protection for any equipment connected to them. The NEC allows for the use of either method, provided that the GFCI protection is readily accessible and effectively protects personnel. Portable GFCI devices offer several advantages in temporary power applications. They are easily transportable, allowing them to be moved from one location to another as needed. This flexibility is particularly useful on construction sites, where the location of temporary power sources may change frequently. Portable GFCI devices can also be used to protect multiple pieces of equipment simultaneously, as long as the total load does not exceed the capacity of the device. Furthermore, portable GFCI devices can provide an additional layer of protection, even when GFCI protected receptacles are already in place. This is because GFCI devices can sometimes fail to operate correctly due to various factors such as damage, contamination, or age. By using a portable GFCI device in conjunction with a GFCI protected receptacle, the risk of electrical shock is further reduced. It is important to note that the effectiveness of portable GFCI protection depends on several factors. Firstly, the GFCI device must be properly installed and maintained. This includes ensuring that the device is securely plugged into a receptacle, that the wiring is in good condition, and that the device is tested regularly to verify that it is functioning correctly. Secondly, a GFCI device must be of the appropriate type and rating for the application. GFCI devices are available in different classes, each designed to protect against different types of ground faults. For example, Class A GFCI devices are designed to trip when a ground fault current of 6 mA or more is detected, while Class B GFCI devices are designed for use in specific applications, such as swimming pools. The NEC specifies the appropriate class of GFCI device to use in different situations. Thirdly, the GFCI device must be readily accessible to personnel. This means that the device should be located in a place where it can be easily reached in the event of an electrical fault. The device should also be clearly labeled to indicate its function and purpose. In addition to these factors, it is also important to train personnel on the proper use of portable GFCI devices. Workers should be instructed on how to install the device, how to test it, and what to do in the event of an electrical fault. They should also be made aware of the limitations of GFCI protection and the importance of following other safety precautions, such as wearing appropriate personal protective equipment and avoiding contact with exposed wiring. When selecting a portable GFCI device, there are several factors to consider. These include the device's current rating, voltage rating, trip level, and environmental protection. The current rating should be sufficient to handle the load of the equipment being protected. The voltage rating should match the voltage of the electrical system. The trip level should be appropriate for the application. And the environmental protection should be adequate to withstand the conditions in which the device will be used. Portable GFCI devices are available in a variety of configurations, including cord sets, adapters, and power strips. Cord sets are designed to be plugged into a receptacle and provide GFCI protection for any equipment connected to the cord. Adapters are designed to be plugged into a standard receptacle and provide GFCI protection for a single piece of equipment. Power strips are designed to be plugged into a receptacle and provide GFCI protection for multiple pieces of equipment. When using a portable GFCI device, it is important to follow the manufacturer's instructions carefully. This includes instructions on installation, testing, and maintenance. It is also important to inspect the device regularly for any signs of damage or wear. If the device is damaged, it should be replaced immediately. In summary, portable GFCI protection used by personnel satisfies the requirement to utilize GFCI protection on temporary receptacles, providing a flexible and effective means of ensuring electrical safety in temporary power applications. However, it is important to select the appropriate type and rating of GFCI device, to install and maintain it properly, to train personnel on its use, and to follow all relevant safety precautions. By taking these steps, you can help to prevent electrical shock and electrocution and create a safer working environment for everyone. Furthermore, understanding the specific requirements outlined in Section 305.6 of the National Electrical Code, or NEC, is crucial for ensuring compliance and safety in temporary electrical installations. This section specifically addresses the ground fault circuit interrupter protection requirements for personnel on construction sites and similar temporary power setups. The NEC mandates GFCI protection for all 125 volt, 15, 20, and 30 amp receptacles that are not part of the permanent wiring of the building or structure and are in use by personnel. This requirement applies to receptacles used for temporary lighting, tools, and other equipment. The purpose of this requirement is to protect workers from electrical shock hazards that are more prevalent in temporary wiring situations due to factors such as frequent handling, exposure to weather, and potential damage to equipment and wiring. Section 305.6 allows for several methods of providing GFCI protection. Firstly, GFCI protection can be provided by using GFCI protected receptacles. These are receptacles that have a built-in GFCI device that will trip the circuit if a ground fault is detected. Secondly, GFCI protection can be provided by using portable GFCI devices. These are devices that can be plugged into a standard receptacle and provide GFCI protection for any equipment connected to them. Thirdly, GFCI protection can be provided by using GFCI protected circuit breakers. These are circuit breakers that have a built-in GFCI device that will trip the circuit if a ground fault is detected. The NEC also allows for an exception to the GFCI protection requirement in certain situations. Specifically, GFCI protection is not required for receptacles that are used exclusively for cord and plug connected equipment that is part of an Assured Equipment Grounding Conductor program. An Assured Equipment Grounding Conductor program is a written program that ensures that all cord and plug connected equipment is properly grounded and maintained. The program must include regular inspections, testing, and record keeping. In addition to the GFCI protection requirements, Section 305.6 also includes requirements for the location and accessibility of GFCI devices. GFCI devices must be readily accessible and located in a place where they can be easily tested and reset. They should also be protected from physical damage. It is important to note that the NEC is a minimum standard, and local jurisdictions may have additional requirements for GFCI protection. It is always best to check with the local electrical inspector to ensure compliance with all applicable codes and regulations. When implementing GFCI protection for temporary receptacles, it is important to consider the specific needs of the application. For example, on a construction site, it may be necessary to use heavy-duty portable GFCI devices that can withstand the rigors of the environment. In other situations, it may be more practical to use GFCI protected receptacles. Regardless of the method used, it is important to ensure that the GFCI protection is effective and that personnel are properly trained on its use. In addition to the NEC requirements, OSHA also has regulations regarding GFCI protection on construction sites. OSHA requires that all 120-volt single-phase, 15 and 20 amp receptacle outlets on construction sites that are not part of the permanent wiring of the building or structure and are in use by employees be GFCI protected. This requirement is similar to the NEC requirement, but it applies specifically to construction sites. OSHA also has requirements for the training of employees and the use of GFCI protection. Employees must be trained to recognize the hazards of electrical shock and to use GFCI protection properly. They must also be trained to test GFCI devices and to report any problems. Failure to comply with the NEC and OSHA regulations regarding GFCI protection can result in fines and other penalties. It can also increase the risk of electrical shock and electrocution. Therefore, it is essential to take GFCI protection seriously and to ensure that all temporary receptacles are properly protected. In conclusion, Section 305.6 of the NEC provides clear guidelines for GFCI protection of temporary receptacles. Understanding and adhering to these guidelines, along with OSHA regulations, is crucial for ensuring the safety of personnel working with temporary electrical installations. By using GFCI protected receptacles, portable GFCI devices, or GFCI protected circuit breakers, and by implementing an assured equipment grounding conductor program where appropriate, you can significantly reduce the risk of electrical shock and electrocution. Remember to always consult with a qualified electrician and local authorities to ensure compliance with all applicable codes and regulations. The goal is to create a safe working environment for everyone involved in temporary electrical setups. Consider the implications of using extension cords in conjunction with GFCI protection. Extension cords, while convenient, can introduce additional hazards into temporary electrical systems. Damaged or improperly used extension cords can become a source of ground faults, potentially negating the benefits of GFCI protection. Therefore, it is crucial to inspect extension cords regularly for any signs of damage, such as cuts, abrasions, or frayed wires. Damaged extension cords should be immediately removed from service and replaced. When using extension cords, it is important to ensure that they are properly rated for the load they will be carrying. Using an undersized extension cord can cause it to overheat, which can lead to a fire. Extension cords should also be protected from physical damage, such as being run over by vehicles or equipment. In wet or damp locations, extension cords should be specifically designed for outdoor use and should be equipped with waterproof connectors. It is also important to avoid overloading extension cords. Overloading an extension cord can cause it to overheat and potentially start a fire. To avoid overloading, do not plug too many devices into a single extension cord. Instead, use multiple extension cords or a power strip with a built-in circuit breaker. When using power strips, make sure that they are also GFCI protected if they are being used in a location where GFCI protection is required. In addition to the physical condition of extension cords, it is also important to consider the way they are used. Extension cords should not be run through doorways, windows, or other openings where they can be pinched or damaged. They should also not be run across walkways or areas where they can be tripped over. When not in use, extension cords should be properly stored to prevent damage and tangling. Consider the specific requirements for GFCI protection in different types of temporary electrical installations. For example, the requirements for GFCI protection on a construction site may be different from the requirements for GFCI protection at an outdoor event. On construction sites, GFCI protection is typically required for all 125-volt, 15, 20, and 30 amp receptacles that are not part of the permanent wiring of the building or structure and are in use by personnel. This requirement applies to receptacles used for temporary lighting, tools, and other equipment. At outdoor events, GFCI protection is typically required for all receptacles that are within 6 feet of water or are accessible to the general public. This requirement is intended to protect attendees from electrical shock hazards. In addition to these general requirements, there may be specific requirements for GFCI protection in certain types of temporary electrical installations. For example, there may be specific requirements for GFCI protection in tents, stages, and other temporary structures. It is important to check with the local electrical inspector to ensure compliance with all applicable codes and regulations. Always verify the proper functioning of GFCI devices through regular testing. Testing GFCI devices is a critical step in ensuring that they are functioning properly and will provide adequate protection in the event of a ground fault. GFCI devices should be tested regularly, typically on a monthly basis, or more frequently if they are used in a harsh environment. To test a GFCI device, simply press the test button on the device. This should cause the device to trip and interrupt the power to the circuit. If the device does not trip, it should be replaced immediately. After testing a GFCI device, it is important to reset it by pressing the reset button. This will restore power to the circuit. If the device trips again immediately after being reset, there may be a ground fault in the circuit. In this case, the circuit should be inspected by a qualified electrician to identify and correct the problem. In addition to testing the GFCI device itself, it is also important to test the wiring and equipment connected to it. This can be done using a multimeter or other testing device. The purpose of this testing is to ensure that there are no ground faults in the wiring or equipment. If a ground fault is detected, the wiring or equipment should be repaired or replaced immediately. Remember that GFCI protection is not a substitute for other safety precautions. GFCI protection is an important safety measure, but it is not a substitute for other safety precautions. Workers should always be trained on the hazards of electricity and how to work safely around electrical equipment. They should also be provided with appropriate personal protective equipment, such as gloves and safety glasses. In addition, workers should be instructed to inspect electrical equipment regularly for any signs of damage and to report any problems to their supervisor. By following these safety precautions, you can significantly reduce the risk of electrical shock and electrocution. In conclusion, understanding the nuances of portable GFCI protection, adhering to NEC and OSHA regulations, and implementing comprehensive safety practices are essential for ensuring electrical safety in temporary power setups. Regular inspections, proper equipment maintenance, and thorough training are key components of a safe working environment.